Hello and welcome back once again. I am Amy Fuchsteiner, your instructor for elementary algebra. We are going to present section 3.3 today. This is graphing linear equations. So we're going to talk first about about identifying a linear equation. How do you know one by equation and how do you know one by sight? We're going to complete some ordered pair solutions in order to graph them. Then we're going to plot some points. Now, we're going to use those points to create the actual graph. Then we're going to learn a little less cumbersome method, which uses the intercepts of a line. So you've got to be able to recognize what the intercepts are and then use them to graph the line. We're going to talk then about some special cases, the horizontal and vertical lines. And lastly, we want you to be able to use the graphs of some linear equations in order to solve some application problems. So this one, I think we're going to go about an hour. We'll see. All right. So goal number one, can you identify linear equations? Linear equations generally involve two variables, an x and a y. The standard form of that linear equation is what we need you to go by. That is the ax plus by is equal to c. That is your standard form of a linear equation. There is a second common form as well. We haven't learned what it's called yet. Some of you may know, but we're going to learn that second common form, I think, in the next section, right? Now, this is our standard form. We also want you to be able to recognize a linear equation based on its graph. So I have here off to the right 4 different graphs. The first one is representative of a linear equation. It is a straight line. This particular linear equation is increasing, that is, it's going up. Now, a linear equation will be a straight line, and it will either climb or fall, or it'll be flat. It is not going to have any changes in direction. What do I mean by that? If you look at this second graph, this is called a parabola. We did have one in section 3.2, we graphed one, but this is not linear. And I know it's not linear because we have that change of direction. It was falling and then all of a sudden it's increasing. That's 2 different directions. So this is not a straight line. The third graph here is the graph of an absolute value. This is also not a straight line. This is not a linear equation. How do I know? Because once again, we change direction. It was coming down and then it flips and goes up, okay? Lastly, we have an example you haven't seen yet. This is an example of a cubic equation. I know this is a cubic because cubic have these sort of S shapes. So this is a change in direction. It was increasing and then it kind of flattens out for a little bit and then it increases again. Cubics have sort of this plateau in the middle and some of them go down and then back up again. Okay. I know that these 3 are not linear. Non-linear, non-linear, non-linear. The only linear equation here is this one. They go in one direction. Sometimes they climb, sometimes they fall, sometimes they're flat. But linear equations only have one direction, right? Okay, so a couple of things we want you to be able to do. We want you to be able to manipulate the linear equation. We want you to be able to take an equation that is not in standard form and put it into standard form. Remember, standard form has your x's and y's on the same side. Ax plus by is equal to c. So if I have an equation that is not in standard form, I want to manipulate or move around that equation so it is. To do that, I want my x's and y's on the same side. They are currently not on the same side. So I am going to subtract this 2x. That will move it off of the right side and put it on the left side. Now I have a negative 2x plus y is equal to, and on the right side, the only thing I have left is a negative 3. This is almost done. The only part that I need to fix here is I cannot lead with a negative. I cannot lead with a negative. And if I want to change that negative to a positive, I need to multiply it by negative 1. And what I do to one side of my equation, I have to do to the other. So this now becomes 2x minus y is equal to 3. This equation is now in standard form. Now, here's the deal. This answer and this answer are the same. They represent the same line. They are just different formats of the answer. It's sort of like when your mom calls you by all 3 names versus calling you by just your first name, right? I don't know what culture you come from, but in my world, when my mother said Amy Kristen Fuchsteiner, I knew I was in trouble. Grandmas can say it kind of in a way where it's like they're just exasperated. They're not really mad at you. But when mom uses all 3 names, you're in trouble. You don't change. You're still you, but it does tell you some information. So why do we have these 2 forms? Because they give us different pieces of information, right? Same answer, different formats. Okay. That means that we can take something that is in standard form, 3x minus 4y is equal to 12, and we can also rearrange it so it's in sort of the nickname form, which is y is equal to. So in order to do that, in order to isolate this equation for y, I'm going to subtract 3x from both sides. That's going to give me a negative 4y is equal to a negative 3x plus 12. The y is still not isolated, so I'm going to divide it by a negative 4. And if I do that to one term, I have to do that to all terms, negative 4, negative 4. That will give me y is equal to 3/4 x minus 12 divided by negative 4 is a negative 3. Okay. We're going to be using this particular method quite a bit, this particular method at some points today as well. All right. So can we complete the tables? Oops. What do I got on my shirt? There we go. All right. In order to complete the tables, the best way to do that is to actually put the line into the y equals 4. But I'm not going to do it just yet. We're going to see. So here I have a table where it's partially filled up. I know what my x value is. I need to find my y value to get the point. So I'm going to take 5y is equal to 2 times that negative 10 plus 10. Negative 10. So that's going to give me 5y is equal to a negative 20 plus 10. So 5y is a negative 10. Now, to get the y alone, I need to divide both sides by 5. And I get that y is equal to a negative 2. This gives me a point at negative 10, negative 2. That gives me the coordinate pair, negative 10, negative 2. For the second one, I know that y is 0. So now I'm going to put the 0 in for the y, and that's going to be 2x plus 10. If I put 0 in for that y, that gives me 0 is 2x plus 10. Oops, I forgot my 1. To solve this for x, I need to subtract 10 from both sides. So negative 10 is a 2x, and then divide both sides by 2. So negative 5 is equal to x. And this gives me the point negative 5, 0. So far, so good. I got one more mini problem to go. I've got a 5 times y is equal to, Yeah, no, I don't know what that is. 5y is 2 times my x value plus 10. So that's going to be 2 times 5. So I've got 5y is 10 plus 10. So 5y is 20, because I can do those. Then to isolate the y, I need to divide both sides by 5. And I get y is equal to 4. So that gives me a y value of 4 and a point of 5, 4. Okay, beautiful. Each one of these sort of becomes its own mini problem where I'm solving for either x or y. It depends upon which one I got. When they gave me the x, I solved for the y. When they give me the y, I solve for the x. Right? Now, some of you are saying, okay, Amy, but there is a faster way. There is. If we are to isolate the y first, so I'm going to take this and I'm going to subtract 3x from both sides. That's going to give me a negative y is equal to, I cannot combine those, so I'm just going to rewrite it as negative 3x plus 2. Almost done. The y is still negative. I don't want it to be negative, so I'm going to multiply it by a negative 1. And if I do that on the left side, I have to do that on the right side. That's going to give me y is equal to 3x minus 2, right? Negative times a negative is a positive, negative times positive, negative. So now I have, like we were doing yesterday or earlier, I have 3x minus 2 there. So my unknown y here would be 3 times the 0 minus 2. Well, that's just going to be minus 2. And for this one, I know the y, so negative 8 is 3x minus 2. Add 2 to both sides. That's going to be a negative 6. Divide by 3 is a negative 2. And on the last one, I have y would be 3 times the 8 minus 2. That's 24. Minus 2 is 22. And I have my 3. Do you see how this was faster than this one? Both are correct. This one's just a little bit more efficient, particularly if you have some strength in mental math, right? Okay. So the next thing we want to kick this up to is, how do you use the table to plot some points and graph a line? So here I have outlined the steps. The first thing you want to do is isolate your y value. Then we're going to choose 3 values for that x. Normally we would choose one positive number, one negative number, and 0. Okay? If you've got a fraction, like we talked about last time, you want to use multiples of that denominator. Don't worry about the numerator, worry about the denominator. We're going to substitute in the x values to find the y values. This is going to give us the point xy. Now we're going to plot each one of those points and draw the straight line through those 3. What does this look like? Well, if you've already got the y isolated, such as y is equal to a negative 3x, your y is already solved for, so you really just need to pick 3 x values. The first x value should be negative, like a negative 1. The second x value can be 0, and then a positive x value. This is perfectly fine. Don't make the numbers too hard. You get to pick. Mathematically, we like to see what's happening in the negative numbers. We like to see what happens at 0, and we like to see what happens with the positive numbers. That's why I'm choosing a negative 1, a 0, and a 1. Could I have chosen a negative 12, a 0, and a 2? Yeah, but negative 12 is not an easy number for me to manipulate in my mind. So I'm going to choose the numbers that are easiest, like a negative 1, a 0, and a 1. So if I choose x to be a negative 1, then y would be a negative 3 times a negative 1, which is 3. This gives me a plot to point at negative 1, 3. A point to plot, not a plot to point. All right, if I let x equal 0, then y would be a negative 3 times 0. That's just going to be 0. And I have another point at 0, 0. If I let x equal 1, then I have a negative 3 times 1, which is negative 3, and I have a point to plot at 1, negative 3. Those 3 points should graph onto the line. Negative 1, 3, 0, 0, and 1, negative 3. Now, I believe when you're doing this on WebAssign, you only need to plot 2 points. The third point should check the line. We'll make sure of that and see if we can blast that out for you. Okay? All right. Our second equation, it's already isolated for y. So that part of it is good. Y is equal to a negative 3x plus 4. I know what the y value is equal to. I don't have any fractions. So when I choose my x values, I will simply choose a negative number, a positive number, and 0. Then I will plug them in one by one. For the first value, y is equal to a negative 3 times negative 1 plus 4. That's 3 plus 4, which is 7. And I have a point to plot at negative 1, 7. For the second point, I will let x equal 0. Then y is a negative 3 times 0 plus 4. 0 plus 4 is 4. And I have a point to plot at 0, 4. Lastly, I have y as a negative 3 times 1 plus 4. That's negative 3 plus 4 is 1. And I have a point to plot at 1, 1. When I plot these, I'm going to plot them on the same graph this time because I'm a little short on room. So I'm going to use a different color. I'll use the green. And I have a negative 1, 7. Negative 1, 1, 2, 3, 4, 5, 6, 7. I have 0, 4. And I have 1, 1. So those are my 3 points on this green line. And when I put the line through them to draw a straight line, here I have a second line. This line is y is equal to a negative 3x plus 4. This purple line was just y is equal to a negative 3x. Do you notice anything about those two lines? Is there a name that we have for those two lines? Two lines that never meet and always run in tandem? And once you've looked at those, just look at the equations for a minute. Do you notice anything about the equations of those lines? That could come in handy. Okay. All right. Problem number 3, or example number 3. Example number 3, I have 2x minus 5y is equal to 15. The more efficient way to do this is to make sure that we have solved for y. So I'm going to draw a line down that equal sign, and I'm going to rearrange this equation so that I have solved for y. To do that, I'm going to subtract 2x from both sides. Now, I can't really do 15 minus 2x. Those are not like terms. They cannot be combined. So these will cancel. I'll have a minus 5y is equal to a negative 2x plus 15. 15 minus 2x is fine. I just always like to put my x's first. It's just an order that I've been trained to do, so I do it. All right. In order to continue to isolate the y, I'm going to divide by a negative 5. And if I do that on the left side, I need to do that with each term on the right side as well. Essentially distributing that division across each term. Much like if we were multiplying, we would multiply each term. This will give me y is equal to negative 2 over negative 5 is 2/5 x plus 15 over negative 5 is a negative 3. So I have a y value of 2/5 x minus 3. Do you see how I have a fraction here? I have a denominator. So when I choose my 3x values, I am going to choose multiples of that denominator, one positive, one negative. And to keep this really easy, I'm going to choose a negative 5, a positive 5, and then I'm going to hit that 0 because 0 is always the easiest one. Right? Now, I have y is equal to 2/5 of a negative 5 minus 3. 2/5 of negative 5 is negative 2. So I have negative 2 minus 3 more. That's going to be a negative 5. And I have a point to plot at negative 5, negative 5. The second one puts 0 in for the x. So y is 2/5 of 0 minus 3. 2/5 of 0 is just 0. Anything multiplied by 0 is 0. Minus 3 gives me a negative 3. Gives me a second point to plot at 0, negative 3. My third point is y is equal to 2/5 of 5 minus 3. 2/5 of 5, that's 2. 2/5 of 5 is 2. 2 minus 3 is negative 1. So this is going to be 5, negative 1. With those 3 points to plot, I have a negative 5. 1, 2, 3, 4, 5, negative 5. I have a 0, negative 3. And I have a 5, negative 1. 1, 2, 3, 4, 5, negative 1. Now, when I go to plot these, once I have them plotted, I can graph the line. When I go to graph the line, do you see how the 3 of them do not line up? Yeah, the 3 of them do not line up. That means I have a mistake. Somewhere there is a mistake. So I'll recheck the math. 2/5 of negative 5, that's a negative 2. If I'm not sure, I pull out a calculator and I do 2/5 times negative 5. Yep, that's a negative 2. Minus 3 more. That's a negative 5. So that's right. 2/5 times 0 is 0. Minus 3, negative 3. Okay. Then I need 2/5 times 5. Yep, that's 2 minus 3. That's a negative 1. Okay. So all of these are right. That probably means I counted wrong. All right, so let's try it. 1, 2, 3, 4, 5. 1, 2, 3. Oh, yeah. You see what I did, don't you? It's not that one. It's that one. And then 0, 1, 2, 3. Yep. And 5, negative 1. 1, 2, 3, 4, 5, negative 1. Okay. Now, do those 3 points line up? They do. There we go. There's my graph. This is why we do 3 points. Because if those 3 points create a triangle, we made a mistake. Those 3 points should make a line. If they do not line up, if you were to connect to them all 3 and they would make a triangle, you have an error someplace. All right, let's try the next one. Y is equal to 10 minus 4x. We want to first solve this for y. To do that, I need to divide by 2 to isolate the y. So I'm going to divide the 10 by 2, and I'm going to divide the 4 by 2. That's going to give me y is equal to 5 minus 2x. If you would like, you can rearrange this to y is a negative 2x plus 5. I like to do that because I like my x's first, but it's not mandatory. You will notice at this point that there are no fractions. That tells me that I can pick my x values to be any old numbers I want, generally one negative number, one positive number, and a 0. So I'm going to do a negative 1, 0, 1. In the first point, my y would equal a -2 times a -1 plus 5. That's a +2 plus 5, which is 7. And I have the point -1, 7. For my second point, we're letting x be 0. So this would be a -2 times 0. That's a 0. Plus the 5 is still going to be a 5. 0, 5. And for my third point, I'd have a -2 times 1. That's -2. Plus 5 is 3. And so I have a point at 1, 3. Plotting those on the graph, I have a -1 and then up 7. 1, 2, 3, 4, 5, 6, 7. Look at me slowing down to count it right. 0, 5 is my second point. So starting at 0, 0, I don't go left or right, and then I go up 5. 1, 2, 3, 4, 5. And my third point is at 1, 3. That's right 1, up 3. There we go. This gives me my line. Those 3 points do line up. There we go. I'm trying to get them in a nice line, and then I can graph it. Okay. Oh, we froze. It froze. There we go. Better. Okay. All right. This is also an equation of the line. This is the first one I think that's been falling. Every other equation we've graphed today has increased. It's gone up. This one is the first one that falls. This is still a linear equation. It's only going one direction. It might be down, but it's only one direction. Okay. All right. What do we got next? Oh, intercepts. Beautiful. Intercepts are a great thing. So let's talk intercepts. So when you're graphing a line, or when a line is graphed, it has what's known as intercepts. And intercepts are where the line crosses the axis. There are two intercepts. There is both the x-intercept and the y-intercept. And of course, the x-intercept is where the line crosses the x-axis. And because it's right at the x-axis, because that point is not above or below the x-axis, it always has coordinates x0, where x is some number left or right, but 0 means it's staying right there on that x-axis. The y-intercept is where your line crosses the y-axis. And there you haven't moved left or right, you've only gone up or down. So this point always looks like 0y. The fact that those have the zeros in them become helpful to us, because if I can find the x-axis and the y-axis, as those shift and change, my line will shift and change. So the x-intercept and the y-intercept are unique to each line. So every line has a unique x and y intercept. That means if we can identify those, we have 2 points on the line. The downfall is that the 3 points were very helpful in making sure we didn't mess up. This one only has 2 points. So if you mess up, you're going to get a different line, and you might not know it. Right? So how do we graph using intercepts? It's actually pretty straightforward. We have to find each intercept using the zeros. So for the x-intercept, we're just going to let y equal 0, right? For the x-intercept, notice the y value is 0. So to find the x-intercept, we're going to take any equation they give us, in any form they give us, and we're just going to let y equal 0. To do that, in this case, we would have 4x plus 0 equals 6. So I'm going to put my 0 in, right? That's going to give us 4x equals 6. Now to find the x, I'm going to divide by 4. and we will get x is equal to 6 over 4, which is 1.5. This gives us an xy point of 1.5. And what did we say the y was? 0. So this gives us an x-intercept at 1.50. I'm going to approximate that a little bit, but it would go right over there. So that's over 1.5 up 0. So now to find our y-intercept, we're going to let x equal 0. Right? And if we let x equal 0, then we have 4 times 0 plus y is equal to 6. Well, that's just 0. So our y value equals 6. And this gives us a point, x, y. We let x be 0 at 0, 6. So this gives us a second point at 0, 2, 4, 6. These 2 points are enough to graph the line. But be warned, if either of those points is wrong, you have the wrong line. There's no check built into it like when we had 3 points. You can look at your graph and say, oh, it looks to me, 2, 4, it looks to me like 3, -6 should be on that line. So you could check the point 3, -6 if you want it. Okay, let's try this one again. How do we do this? Well, the first thing to do is to find the x-intercept. So the x-intercept, we're going to let y equal 0. Then I have 2x minus 3 times 0 equals 15, or 2x is equal to 15. That's going to give us x is 15 divided by 2, or 7.5. So my first point will have an x value of 7.5 and a y value of 0. Oh, we're freezing. Okay, let's just try it this way. Okay, then we'll find the y-intercept. And to find the y-intercept, we're going to let x equal 0. It's always the other one. So if you're finding the x, then y equals 0. If you're finding the y, then x equals 0. So this is going to be 2 times 0 minus 3y is equal to 15. So that's going to be -3y is 15. Dividing both sides by -3, y is a -5. So this gives us a second point with a y value of -5. But what's the x? We let x be 0. Plotting these 2 points, I have 7.5, 2, 4, 6, 7, 0. So that's going to be right about there. And then 0, -5. So 0, 1, 2, 3, 4, 5. These 2 points are enough to plot the graph. Notice I've been very specific about the points I found. I found the x-intercept and the y-intercept. My point for you when you're doing this homework is if you're graphing the line but not using the intercepts, it will mark it wrong. If it says use the intercepts to graph and you use some other points other than the intercepts, it will mark the homework wrong. Be forewarned, okay? Why don't we use this all the time if we only need 2 points? It doesn't always work. The x and y intercepts do not always work to find a unique line because there is one place a line can go through that is not at all unique. Here's an example. Here we have the equation x plus 2y is equal to 0. If we are going to find the x-intercept, we're going to let y equal 0. If we let y equal 0, then we have x plus 2 times 0 equals 0, or x plus 0 is 0, which just means that x is 0. This is not a problem. X can be 0. That gives us the point where x is 0 and y is 0. So right there, bing, x is 0, y is 0. Now if I go to find the y-intercept, using the intercept says I'm going to let x equal 0. So I'm going to let x equal 0. This is going to give me the equation 0 plus 2y is equal to 0. So 2y is equal to 0, and y is 0, which gives me the point 0, 0. I didn't get a different point. If you're not going to get a different point, then you can't draw a line because you need at least 2 points for a line. And if I only have 1 point, I have a point on the line, but now I don't know, is it going up? Is it going down? Is it sort of flat? Is it really steep? I don't know enough about it. So I can't use the intercepts here. It doesn't work in this case. I'm going to say, okay, let x equal 1. Right? Or maybe I let x equal 10. Then we have 10 plus 2y is equal to 0. Or 2y would be a negative 10. Dividing both sides by 2, we have y is negative 5. So my point then is 10, negative 5. 2, 4, 6, 8, 10, negative 5. And I need to have that second point to determine my line. We're not stuck. I mean, there are other ways around it. You just need to pick a different x. But you do need to be careful because intercepts are not universal. They don't always work to graph the line. All right, come on. It's being an issue. We're just being fussy. There we go. All right, so where are we in this? Okay. Horizontal and vertical lines, pretty straightforward. We just want to talk for a minute about the difference between horizontal, vertical, and oblique. Most of the lines that we've done so far have been what we call oblique lines. These are lines that go on a slant. They're either increasing or decreasing. The equations of oblique lines tend to look like the standard form ax plus by equals c, or the form where it's isolated for y, looking like y equals mx plus b. They have both an x and a y in the equation. Oblique or slanted lines go in 2 directions at once, left and right and up and down. So they have both an x and a y in the equation. Horizontal lines go straight across. Horizontal lines never go up or down. They only go left or right. And here's the crazy thing. Horizontal lines tend to look like, that should be a C, tend to look like by equals c. Some number multiplied by y is equal to c. Vertical lines have only an x in them. So how do I know when I have a vertical or horizontal line? I know I have a vertical or horizontal line when one of the letters is missing. And from there, I just need to know which letter goes with which. Here's the thing. It's opposite the axis. So if you have an x and no y's, then it has to cross the x-axis, which means your line will need to be vertical. If your equation has a y and no x's, then it needs to cross the y-axis, which means it will be horizontal, right? If your line has both an x and a y, then that line is oblique. It is slanted and it must cross both axes, both your x-axis and your y-axis. Now, are there shortcuts for this? Yeah, the biggest shortcut of all is just to memorize. Just know that if you see x is equal to a negative 3, that this is going to be a vertical line because it has to cross the x-axis at negative 3. So I'm going to find x equal to negative 3, and I'm going to draw through there the vertical line. This is it. It's a vertical line that has to go through the point negative 3, 0. Similarly, if you have an equation that looks like y equals 2, recognize right away that this is not going to be a slanted line. There's not two different letters in it. It's just a y equals -2. So this line will be either vertical or horizontal. Since I know y can be 2, on my y-axis, I can find 2. Y is at 2. And the only way to go through that point is to be a horizontal line. This is a horizontal line through 0, 2. Okay? Now, if you need a little trick for your brain, here's what I've got. It's not much. All I've got is I used to spell it horizontal. Instead of saying horizontal, I would say horizontal. And that was my clue that the y equals was a horizontal line. It ain't much, but it might work for some of you. Okay? All right. The last goal is to use graphs of linear equations to solve application problems. I think I've got 2 examples here, maybe 3. What do I have? 2 for sure. Yep, I got 2. Yep, 2 examples. All right, so let's talk. Let's look at this. So each semester, the college charges a base service fee of $1,200 plus $200 for every credit that you take. We want to write a linear equation that represents the enrollment fee F for a student who takes C number of credits. We're going to complete the table of solutions and graph it. Then we're going to answer some questions based on the graph. So the college charges, a little bit at a time. First of all, restate this. The college charges $1,200 plus $200 each credit. This is the fee. So our fee is made up of $1,200 plus $200 each credit. They want us to use the letter F for the fee and C for the number of credits. That's part A. The fee is $1,200 plus $200 a credit. I'm going to put the credits first, so I'm going to put this as 200C plus 1,200. The second part says to complete the table of solutions. So here's my part B. What does this mean? Well, this is saying if somebody takes 3 credits, then their fee would be 200 times 3 plus the 1,200. That's going to be $1,800, or 3 credits at $1,800. If somebody takes 9 credits, that's going to be 200 times 9 plus the $1,200. That's $1,800 plus $1,200, or $3,000. So 9 credits is going to cost approximately $300. If someone takes 12 credits, that's going to be $2,000 times 12 credits. That's $2,400 plus another $1,200. That's $3,600. So 12 credits would be $3,600. These 3 points of the relationship are enough to create the graph. Notice on the graph, I've only done the first quadrant because you don't owe negative money. I'm not taking any courses. That's a -3 credits. The college pays me. It doesn't work that way. All right, so I'm only using the first quadrant. The credits would go along the x-axis. So these would be our credits because notice that's in the x place and that's in the y place. So 1, 2, 3, 4, 5. I'm just going to mark some of these so I have a reference. 6, 7, 8, 9, 10. 11, 12, 13, 14. So I'm just going to mark some of these. And then across the y-axis, notice it's the second one, or the independent variable. or the dependent variable. Sorry, that's the dependent. This is the independent. We'll get to that later. This is the y value, so this is our fee in dollars. And we need to go from 1,800 to 3,600. So I don't want to count by one. I want to count by something else. So I think I'm going to count 2, 3. I'm going to count by 400, I think. That might work. Or maybe I'll count by 300. I think I'm going to count by 300. So 300, 600, 900, 12, 15, 18, 21, 24, 27. Yeah, that'll work. 3, 3, 3, 3,600. And that's 4,200. Okay. So I've counted up the y-axis by 300 so that I can get what I think are going to be pretty nice numbers to graph. So at 3, I'm at 1,800. That's nice. At 9, I'm at 3,000. That should be right about there. And at 12, I'm at 3,600. Yeah. Okay. So now hopefully these create a line. They do. Very nice. And this works because we know if they don't take any credits, they should still be at $1,200. So 0, 1,200, that works. Okay, so I've done the table, I've done the graph. So there's C, part C. Part D. Based on this graph, what is the cost for a student taking 10 credits? So I'm going to find the 10 credits. I'm going to follow this up. And I'm going to say, okay, if they're taking 10 credits, that would be right there. So 10 credits would be, about $3,200. If I had to guess where that would go, I'm going to go there. I'm going to follow this across. Remember, that would be 3,300 because I'm jumping by 300. So I'm going to say about 3,200. Okay. What are the coordinates of the y-intercept? The y-intercept is where we cross the y-axis. That's right there. So that's going to be 0, 1,200. What does that tell you? That tells me if somebody enrolls in college, but they don't take any credits, they still owe $1,200. Now, that might not be the actual reality of it, but that's what the y-axis tells us here. That if they take 0 credits, they still owe $1,200 in fees. Right? Okay. We wrote the equation, we used the table, graphed the line, and I answered a couple of questions. I think I got one more. One more, because when it comes to the word problems, there's never enough examples. Oh, these are about platypi. Platypuses, platypi are some of my favorite animals. Okay, so now I remember making this problem. So platypi detect prey through electromagnetic receptors in their bill. This is true. This is true. Research has determined that the speed at which their prey is detected is related to the density of the receptors. So how many receptors they have determines the speed at which they can detect their prey. I'm making this up now. The resulting equation is S, or speed, is equal to 5 minus 3/8 d, where S is the speed of detection in seconds, and d is the density of the receptors by the 100. So if D is 2, that means it's really 200 receptors per whatever. And if it's D is 5, it's really 500 receptors. Okay. So I've given the equation. Oh, good. I gave the linear equation. S is equal to 5 minus 3/8 d, where S is the speed in seconds and D is the density of the receptors. Great. Okay, complete the table of solutions below. All right, so part A is to complete this table. Okay. So D is the density. So that's 4, but we really mean 400 receptors. Then the speed. So for D equals to 4, S would be 5 plus 3/8 of 4. Okay, that's a fraction. I don't like a fraction, but I got a tool. All right, I'm going to do 3/8 times 4. That's 1.5 plus 5 is going to be 6.5. So my S is 6.5. So my first point is at 4, 6.5. Oh no, it's not plus, it's minus, isn't it? This is what happens when you copy the problem wrong. Minus. Okay. So now I'm going to do 5 minus 1.5. That makes sense. 3.5. Okay. I got to subtract rather than add. Second one, S is equal to 5 minus 3/8 of 6. So that's 600 receptors. So 3/8 of 6, 3/8 times 6 is going to be 2 1/4. If I do 5 minus that answer, I get 2 3/4. All right. And then for 8, well, 3/8 of 8 is 3. I know that one. So S is 5 minus 3/8 of 8. That's just going to be a 3. So 5 minus 3 is 2. And that gives me 8, 2. All right. Okay, so I have completed the table. Now I want to graph it. I think I can just do, well, this is on halves and fourths, but I don't think I have enough. I might go by 2s. So I might make that 1, make that 2, make that 3, make that 4, 5, 6, 7. If I count 2 as 1, then I can put the 1/2 in a nice spot. I'm just giving myself a little room to breathe when I graph this. So 1, 2, 3, and then this can be 4, 5, 6, 7, 8, 9, 10, 11, 12. These are kind of, whoops, this one, 16. All right, so now when I plot these, this horizontal is the density in hundreds, and the vertical is the speed in seconds. Okay, so my first one is 4 and then 6.5. So if I go over 4, then I can go up 6.5. And do you see how, because I skipped, I get to make a nice 1/2? My second one is at 6, and that's going to be 2. Oh, that seems, oh, it should be 3.5. I'm still plotting the old one. Ugh. 4 is 3.5. There we go. I was plotting the plus. And then 6 is 2 3/4. Right about there. And then 8 and 2. Okay. All right. So here we go. There's my line. And now I'm going to graph it. Okay, it's a falling line. That makes sense. The more dense the receptors, the speedier they're able to target their prey. All right, so I've graphed it. Based on the graph, how long would it take a platypus with 1,600 receptors to detect its prey? Well, 1,600 is way over here. It's off the graph. Remember, this is 16, but it's in hundreds. So when they ask me about 1,600s, they're really asking about 16 in general. And basically what happens here is that according to this, if it had 1,600 receptors, it could detect its prey instantaneously. In the real world, what this means is probably that 1,600 receptors is not a possibility. This would be a better question if they asked about 1,200 receptors. because 1200 receptors seems to be a possibility, and it's going through 1/2. So if we had said 1200 receptors, we would have said 1/2 second to detect their prey, because that's 12 and 1/2. If we leave that at 1600, it doesn't make sense, because that's off the charts and probably means that they can't have that many receptors. Okay. List the coordinates of the y-intercept. What does that tell you? The y-intercept is over here, and it's at 0, 5. And this tells me that if we have 0 receptors, then it's 5 seconds to find the prey. I'm sorry, to detect the prey. Right? So let's see. C I had to mix up a little bit, and there's D. So C was not my best question. All right. So hopefully you've had some luck with what we've done today. You are able to identify a linear equation. Recall, how do you know if an equation is linear? You can complete ordered pair solutions in order to solve linear equations. You can graph a line by plotting points or by using the intercepts. You can graph horizontal and vertical lines. And you can use graphs of linear equations to solve some questions about application problems. If you have any questions about anything or need any of these clarified, please don't hesitate to contact me, or take your questions to the Math Center, which is drop-in and available most days until 8 o'clock. All right. Thank you very much, and have a good night.